Okay, today's video is going to be all about Bohr diagrams, and what this is it's how we represent our electrons that are inside of our atoms. So we have our nucleus in the middle, as you can see by the picture on the left. Our nucleus is in the middle, and you should be remembering from last year that inside the nucleus is the protons and the neutrons, and then you should also be aware that the electrons are around the outside of the nucleus. What you're going to be learning is that these electrons come in shells. We fill our shells from the closest to the nucleus further out, and each shell can hold a certain amount of electrons. So let's quickly recap our protons, neutrons, and electrons. So you should remember that your protons are positive, and you should remember that your electrons are negative. That would leave our neutrons, which are with the protons in the nucleus, as being neutral. So they're just space fillers. Think about having things like magnets. If you have the positive things close together, they push each other apart, and the same thing goes with having negative things close together, they push each other apart. So inside our nucleus, our protons are very, very close together. They're quite compacted. So we need those neutrons to keep the protons away from each other. Okay, so you should remember your nucleus, your protons and your neutrons. You should remember that electrons are contained in shells that surround this nucleus. The atom is made up of mostly empty space, and that's to do with the electrons and the electron shells. That your protons, the way I like to remember it is P for proton, P for positive, N for neutrons, N for neutral. And then to help me remember that my electrons are negative, I like to think of electrons like electricity, electron, electricity, and that they are negative. No one wants to get an electric shock. So let's quickly recap with this picture. We have our nucleus in the middle. Let me just change my pen color. We have our nucleus in the middle with our protons, neutrons and protons inside here. We have our electrons around the outside. Our electrons are negative, our protons are positive. That little plus sign where our T is. Okay, now we're going to cover how many electrons can go into each shell. Depending on what period number it is in, that will tell you how many shells you need to have in total. Each shell that you have can only hold a specific number of electrons. So if you have a look at the diagram on the left here, if you have one shell, we call that shell the K shell, and that can hold 2 electrons in total. So if I'm filling my electron shells, I fill from the inside out. I fill my number 1 shell or my K shell first, and I'll put 2 electrons into that. Then I would go down to my second shell. My second shell is also known as my L shell, and I can put 8 electrons into that one. My third shell can hold 8, and my fourth one can hold 18. Now remember, we only need to worry about doing the first 20 elements at this stage from the periodic table. So this is all that you need to worry about. There is a point where they start to not necessarily fill in the same similar pattern, but this is all that you need to worry about for now. 2, 8, 8, 18. And I strongly suggest that you write this down into your books, because you're going to need it for later on, so that you can draw your electron configurations, so that you know how these elements are going to interact with each other, how many electrons they want to gain, how many electrons they want to lose when they're reacting with other elements on the periodic table. So each shell can hold a certain number of electrons. We fill from the inside closest to our nucleus and out. My noble gases, if they're in group 8, the end of the periodic table, then it's going to have a full electron shell. If it's not in group 8, then it's either going to have, it will have less than the total amount that it can hold. So if it's in group 1, it will only have 1 electron in its outermost shell. So let's go back to our periodic table. We were saying that as you go down the period, so these guys here have 1 shell. These guys here are in period 2, so they would have 2 shells. This row here would have 3 shells. So this is my 1 shell, 2 shells, 3 shells. And my atomic number is the smaller number out of the two. My mass number is the larger number. So my atomic number is the one that's up the top here. And that tells me how many electrons I need to have in total. So what I know is that my periods tell me how many electron shells that I need to have. My atomic number tells me how many electrons I need to have in total. I need to fill from the inside out. My first shell can hold 2 electrons, and I know this because in my first period, there is 2 elements from my periodic table. 2 electrons in the first electron shell. The second one can hold 8. But if I'm looking at something like beryllium over here with 4, it needs to fill the first shell and then fill the second shell. So it will put 2 into the first, 4 minus 2 leaves me with 2 more left. So I'd put 2 electrons into the second shell. And then it just goes on and follows the same pattern. So if I was going to look at silicon over here, 2 electrons go into the first, which leaves me with 12 left. My 8 go into the next electron shell, and that leaves me with 4 more that I then need to put into the third shell. So it would be 2, 8, 4. 2 in the first, 8 in the second, 4 in the third. Your valence electrons are the electrons that are in the outermost shell. So if you're asked to draw the valence electron configuration of an element, then all you need to show me is the outermost shell. Just the outer shell. I don't care about any of the other middle elements. Valence electrons, outermost electrons. They're the ones that interact with the elements that are around them. The number of shells is the same as the periodic number. Remember, the period number, same as the number of electron shells. And that atoms will try to gain or lose those electrons. So if it's already got a full outer shell, then it's already pretty happy. But if it's one short, so say it had 7 electrons in its outer shell and it wants to have 8 to have a full shell, then it's going to try as hard as it can to try and steal 1 electron from somebody else. But if it has 1 electron in its outer shell and its shell before it is that preceded that one is full, it's going to do all that it can to get rid of that 1 electron so that its smaller shell is full instead. So that's what's happening in this picture here. My sodium is more positive because it lost a negative electron, where my chlorine over here is negative because it gained an electron. Remember, my electrons are negative, so if I'm gaining a negative thing, I become more negative. If I'm losing a negative thing and my negative and positive were even, then I now have more positive than I have negative. So now you need to practice how to draw your diagrams. So the first thing that you need to do is find where the element is on the periodic table, because that will tell you how many shells you need and how many electrons you need in total. Once you've done that, you've determined the number of electrons. It's going to be the same as the atomic number, and that's how many electrons you need to draw in total. So if we have a look at carbon here, we know that its atomic number was 6, so we need to put in 6 electrons in total. So if it's in the first row, 1 shell, the second period, 2 shells, the third period, 3 shells. Try and remember that. So let's have a look at carbon. Carbon was number 6, hydrogen, helium, lithium, beryllium, boron, carbon, number 6. So it's in the second period, so it has 2 shells. So the first thing that I need to do is draw my 2 shells around my nucleus. Okay, so in total I needed to have 6 electrons, and I know that my first shell could hold 2 electrons, so I'll add my first 2 electrons in here. You can represent them with dots, with crosses, with E's. It's up to you how you choose to do it. So I needed to have 6 in total. I've put down 2. How many more do I need? 4. So my 4 other electrons need to go into the second shell. So let's do a quick recap. I needed to have 2 electron shells. 1, 2. I put my 2 electrons into the first shell, and that left me with 4 more to go into the second shell. The best way to draw them is to draw them in pairs, because it makes it easier for you to count later on. So if I put 2 lots of 2, that gives me my 4 in total, and then that way you've got your, just makes it easier for you to count when you're trying to work out how many more electrons it needs. If you have them all spread out around the outside, you're going to be counting them one at a time, whereas this way it's easier to go 2, 4, it wants 8, it needs to gain another 4. So it's not too hard. Once you've done that, you need to make sure that you've checked everything. So do you have your 2 electron shells? Do you have your 6 electrons in total? Do you only have 2 electrons in the first shell? Do you have up to 8 electrons in the second shell? And then up to 8 electrons in the third shell? And then again, 18 in the fourth. Now what I want you to do is to have a go at drawing the first 20 elements of the periodic table into your book. It shouldn't take you too long and it shouldn't be too hard. Remember to double check that you have the right number of shells and the right number of total electrons for your element. Good luck.